In this video, I'll be talking about stream processing with Apache Kafka and Samza. Through the projects in this course, you've been looking at various methods of doing big data analytics. Specifically, you looked at batch processing using frameworks such as MapReduce and iterative processing using frameworks such as Spark. Now, the typical use case of these processing methods is that you have some sort of input data, you feed it into your batch or iterative processing framework, which runs a job and number of tasks on a cluster of machines and produces some kind of output data. Notice that the input data and the output data for a specific batch or iterative processing job is fixed. When the job or task spins up, it looks at the input data, assesses its size, partitions it into individual chunks or pieces, and then spreads it across the cluster of machines in order to do the processing. So once a job that is batch or iterative in nature starts, then the input data cannot change. Now let's look at a different type of processing system, which is stream processing. In stream processing, you can process data in real time, and you have data that arrives in the form of a continuous stream. Now, this stream needs to be handled by some sort of framework that is able to process the stream and produce some kind of output. The output is also in the form of a stream, and in keeping with the theme of big data analytics, we know that we can't use a single machine to process the stream. Typically, it'll be in large volumes, so you'd need to use a cluster of machines. Now, stream processing is extremely popular and has multiple use cases, especially for large web services companies. Companies are looking into stream processing to do real-time decision making and also do real-time analytics. In our stream processing framework study, we are going to look at Apache Kafka. Now, Kafka was built by engineers at LinkedIn and then open sourced as an Apache project. So Kafka is only one part of the stream processing solution. Kafka is a high throughput distributed messaging system. It has a number of properties that are useful for stream processing in that it is distributed among a cluster of machines, it is partitioned, and it also has the idea of all of its messages stored in a commit log in a particular order. One thing that's important to note about Kafka is that Kafka merely organizes and manages the data, the incoming data stream, but it doesn't actively process it. The messages that are generated by Kafka are then passed downstream to some sort of consuming process, which we will see very shortly in this video. So let's run through a bunch of concepts in Kafka. Kafka maintains a feed of messages in categories called topics, and topics are further subdivided into partitions. The processes that publish these messages to a Kafka topic are known as producers. The processes that subscribe to topics and then process the feed of published messages, those are known as consumers. The individual Kafka servers that handle these messages and then replicates or persists them, they are known as the Kafka brokers. So let's take a closer look at how Kafka partitions work. Messages in a partition are maintained in a commit log. And Kafka has the nice property that all of the messages within a partition are ordered and will be delivered to the consumers in that particular order. So this property can be leveraged by a consuming process if needed. Another property of a Kafka cluster is that when you set up a Kafka system, you can actually mention how long you want to keep messages in the system. You can basically retain them for any specific user configurable amount of time if you ever need to replay them in the future. So Kafka is only one part of the stream processing solution. The other part is Apache Samza. Now, Samza is an actual stream processing system, unlike Kafka, which is just a messaging publish-subscribe system. Samza is designed to be paired with Apache Kafka, and it runs on top of Yarn. If you remember our discussion on Yarn in the cloud computing course, basically what that means is that you run some sort of Samza Yarn client, which then interacts with the Yarn cluster's resource manager and node managers, and then is able to run individual Samza tasks in the cluster. So let's take a look at a typical Samza job. A Samza job can take multiple input streams and then produce a certain number of output streams. So here we have an example of multiple input streams. These input streams are then passed on to tasks, which then produce a number of outputs. It's important to note that a Kafka topic is basically equal to a Samza input stream. And a Samza is essentially the consumer of the outputs of a Kafka system. Now, a Samza job, as we just mentioned, can consist of multiple tasks, and these are typically scheduled by yarn. And each task can consume data from any number of streams and produce any number of output streams. Now, let's take a closer look at the idea of state in stream processing. Stream processing can be categorized, at least with Kafka and Samza, into two types. We have stateless jobs. In stateless jobs, a message is processed independently without referring to or modifying some form of distributed state. And then we have the idea of stateful jobs. In a stateful job, a message needs to be processed by referring to or modifying some form of shared state. Typically, the shared state in a stateful job in Samza can be maintained in some type of distributed key value store. So here we have the same example of an input stream being processed by a number of tasks, generating an output stream. Only here we have an additional entity, which is the key value store, which can basically store some kind of distributed state that the tasks can refer to or modify as they produce the output stream.